My name is Devil Burger. Excuse me. My name is Devil Burger and I'm the Big C South Africa Country Chair. I will be moderating the webinar today and also update you on recent developments at Big C. I am a freelance ICT consultant, project manager and Big C certified trainer at the Professional Communications Institute. I've been in the telecommunications, structured cabling and optical fiber industry for more than 40 years. My areas of expertise include ICT infrastructure installations, planning and design, project management and training. I started my journey with Big C in 1991 and obtained the RCDD and land specialist designations in 2002. I hold several data center design credentials and am an active member of the SA Bureau for Standards Technical Committee for Optical Fiber Standards. Before we continue, please take note of the housekeeping rules listed at the bottom of the slide. Please ensure that your microphone is on mute. This function can be found at the control panel. Should you have any questions for myself, Big C or the presenter, please submit them through the Q&A functionality in the control panel. There will be a survey that will pop up on your screen at the end of the presentation. Please check the boxes and submit your answers. The CECs for this webinar will also automatically be reflected on your Big C profile within 30 days. A recording of this presentation will be posted on the weekly website within 30 days. At this point, we need to say thank you to our sponsor for today, Leviton. Thank you for sponsoring this webinar. Let me tell you about some of Big C's virtual offerings. Big C has been working hard to counter the effects of this global pandemic to continue to be able to deliver the same high quality products and services to the ICT community. This is achieved through virtual instructor-led technical workshops or VILT workshops. These workshops are 6-hour events broken into multiple training sessions for an optimal learning experience led by ICT industry experts who cover emerging technologies, best practices and standards. Also, webinars like this one that we're doing on hot topics. Virtual classroom training that combines the best of traditional classroom training with the convenience, with the convenience and flexibility of a real-time virtual learning format. Virtual master classes are exclusive training opportunities that are 3 hours in length, covering a single topic. Virtual master classes are hosted by one or more leading industry presenters touching upon the latest ICT topics. Then we have the VICT forums. These are virtual ICT forums in a 2 to 4 hour format that offer the perfect setting for personalized networking with and presented by industry professionals around the world. They help expand your ICT knowledge on topics that are relevant for you for the day-to-day and make your new industry contacts. ICT forums allow you to catch up on the latest technology and product offerings from international manufacturers, distributors, and suppliers. Big C are running several 30-day promotions after this event. The first of this is the new individual membership joining fee to be waived. If you sign up within 30 days after this webinar, you will be exempt from paying the joining fee by using the code, as you can see on the screen, EMEA-WEB03 when you check out. The final promotion available to you for 30 days after this webinar is a 10% discount on all the Big C standards and technical manuals. Big C has a wide variety of technical manuals, publications, and standards. These are valuable reference points and resources on projects around the globe. The manuals and standards are vital to help you getting your Big C credentials. Please take some time to visit the Big C website and learn more about them. In order to get the 10% discount, please use the code EMEA-WEB03 as displayed on the screen. BICSI's also got the promotion on e-learning courses. Some of these are free or discounted. Topics here include data center, intelligent building, optical fiber. These courses give you an excellent opportunity to learn more about the chosen topic. Personally, I have found these to be invaluable, and plus, you also get CECs for these. Then the BICSI EMEA flagship event, the 2020 BICSI EMEA conference and exhibition, which had to be postponed due to the global pandemic, will now be held on the 6th to the 8th of September at the Sheikh Maktoum Hall in Dubai World Trade Center. Please save the dates of the 2020 EMEA conference. It would be great to see you there. Last year, this event welcomed over 500 delegates, had 50 plus exhibiting companies. Attendees from 32 countries were there, plus 20 industry expert speakers. The conference will feature keynotes, a panel discussion, and technical presentations by the international experts, sharing the latest advancements in the world of ICT and ELV. In addition, the conference hosts an exhibit hall, a BICSI theater where companies can give short presentations on their latest innovations, a technology showcase turning new projects and services from multiple exhibitors, plus pre-conference masterclasses. Those masterclasses are brilliant. Visit our website and register if this sounds like something that you would like to be part of in September. These are some of our confirmed sponsors, travel partners, and supporting associations and organizations of the 2020 conference. If your company would like to participate, please contact us at emea@bixi.org. I repeat, emea@bixi.org. Now we get to the most important part with our speaker for today is Babu Khan. Babu has over 33 years of experience in the ICT industry. He is the Senior Technical Manager for Leviton in the Middle East. And Babu is going to talk to us about our topic today. Over to you, Babu.
Many thanks for that introduction, Tewald. Hello and welcome everyone to today's webinar covering enterprise wireless network planning. Roughly about 55-minute presentations today will cover wireless demand, planning, and preparing for the long term, emerging wireless standards like 802.11ax, and where 5G cellular fits in your network planning. So we will be focusing on gaining a better understanding on different enterprise wireless network options that we currently have today. And in the future, we will discuss which options will give us the highest return on investment. So we will be covering current and future options, including the emerging Wi-Fi 802.11ax and cellular 5G technologies. And we will conclude our webinar with our recommendations. As we already know, there are so many wireless options and there are so many terms like 10 gigabits per second, Cat6a, 802.11, wave 1 and wave 2, and so on. And if you throw cellular into this mix, like 4G and 5G, it gets even more confusing. And some of these technologies and terms are interrelated and can be confusing. And some of these technologies and terms basically interchangeably, we can use them. But sometimes we do use these incorrectly. So as we go through this content today, I will try to clarify what these all means so we can reference them better in the future. This slide, it's slightly longer, so bear with me for a couple of minutes on this slide because I need to make sure that everybody is in sync with what we are going to talk today. So let us begin by looking at the wireless families first. So basically, there are two types of wireless families. We have a Wi-Fi family and we have a cellular family. And sometimes cellular is called mobile. For consistency, we will refer to it as a cellular for today's webinar. So Wi-Fi and cellular share a lot of similar technologies because they both use radio frequency to transmit signals. But what I'm going to focus on this slide is what the main differences are. The first one is the standards body. They are specified by a different standards body. Wi-Fi is specified by IEEE, which stands for Institute of Electrical and Electronics Engineers, and cellular is specified by 3GPP, which is Third Generation Partnership Project. And because they are controlled by a different standards body, they have a different name. Wi-Fi standards are called 802.11, as we all know, with some type of letters following that. And cellular uses the letter G, which with numbers in front of it. And you are probably more familiar with the cellular family name because of the cell phones. We now have 802.11ax from IEEE and 5G from 3GPP. Use of frequencies is another difference. One of the most important element in wireless transmission is frequency. And we will talk more about frequency later today, but basically Wi-Fi runs on unlicensed frequencies versus cellular runs on licensed frequencies. So what this means is that for cellular networks, the government licenses these frequencies to service providers. So it requires paid subscription. That is why cellular services are much more expensive than Wi-Fi services. Now, there is a discussion about 5G using unlicensed frequencies, but 5G cellular network for enterprise has not been well defined. So we are going to stay with what we currently know. And lastly, there is an in-premise cabling requirement for Wi-Fi networks. For example, if you currently have a device that is connected to Wi-Fi network, that device is getting signals from a wireless access point installed somewhere in the building. And that wireless access point is wired to a switch through Ethernet cables, such as Cat6 or Cat6a. On the other hand, cellular does not require in-premise cabling. So if you have a device that is connected to a cellular network, you are getting the wireless signal from cell towers around the location. And again, this is as of today for enterprise space. So these are basically the main differences between Wi-Fi and cellular, and what is the reason that these two families are so different. Let's look at some data. You can see how fast IP traffic is growing. This is the data from Cisco Visual Networking Index. Interestingly, wire connection has not decreased. In fact, it is still growing, as you can see in the purple bar, but a lot of them have been replaced by wireless networks. For example, in 2015, more than 50% of data was running on wire connection. In 2020, the wire connection will drop to 33% of the total IP traffic, and more than 65% of data will be expected to run on wireless, either on Wi-Fi, cellular, or both. So it is very evident that wireless has become so important in our lives that it changes the way we communicate. It changes the way we work. and it changes the way we live. So that is why it is important to talk about and have a good understanding of these two wireless options. We will cover the Wi-Fi options in the first half of the webinar, or the majority of the webinar actually, and 5G cellular in the second half or later part of the presentation. As I explained earlier, Wi-Fi is specified by IEEE. The very first Wi-Fi specification was released in 1997, if some of you may recall, and it has gone through 5 major advancements, and now we are at the 5th generation of Wi-Fi. Now, most of you are probably used to seeing names like 802.11a, G, N, and AC, and so on. Recently, Wi-Fi Alliance, which was originally created by the members of IEEE, developed a new naming system to make Wi-Fi simpler to identify and easier to remember. So they started calling Wi-Fi 1, 2, 3, 4, 5. So the 5th generation of Wi-Fi, which is 802.11ac, can also be called Wi-Fi 5. Now, this is the chart showing different parameters for 802.11 specification. I am not going to go through all these numbers, but what I like to highlight here is that all of these numbers and the technologies, the techniques are really to achieve this maximum throughput. Because of the end of the day, what really matters is the performance, how fast and reliable our network is. And as I mentioned already, there have been multiple rounds of development to ensure that our technologies meet the fast growing demands. So let us briefly go through some of the important differences between these standards. First, the speed is the main difference, as we all know. You can probably see by looking at these numbers that IEEE 802.11ac wave 2 has the fastest speed. So as an example, 802.11ac can transfer a 5 GB file in just 6 seconds versus wave 1 takes about 33 seconds for the same file. So just going from 802.11ac wave 1 to wave 2, you are gaining about 80% faster speed of your network. But this can make a huge difference in workplace efficiency. So speed is the main and the most important improvement of these evolving technologies. The next one is the frequency. Now, as I mentioned earlier, frequency is very important in wireless because in the wireless world, there has always been a trade-off between speed and range. And one of the main reasons is because of this frequency. So wireless signals can run on 2.4 and 5 gigahertz frequencies. The 2.4 gigahertz has narrower bands, and it is currently used by many legacy and current devices such as cordless phones, microwaves, Bluetooth, and some of the older wireless access points. So it is very crowded and it does not provide a very clean and fast signal. On the other hand, the 5G frequency has a wider band and there are less devices using this frequency. So you can achieve faster, cleaner, and less interference signals. But the wavelength in 5 gigahertz frequency is much shorter than the wavelength in the 2.4 gigahertz frequency. The signal with a shorter wavelength means that it cannot easily pass through walls or obstacles. So it is more vulnerable to obstructions and more sensitive to obstructions. So you must be closer to the transmitter to be able to get a good signal without a lot of interferences. And this is the reason why higher frequencies can provide a faster speed but less coverage. So the big question here is, how can we achieve the speed and coverage at the same time? And this is where a good infrastructure design comes into play, which I will discuss later today. Before we talk about the design, let's take a look at the cabling requirements. And I believe this will make a very good transition to the design section. So the older devices such as 802.11an and G required category 5E and category 6 cabling and connectivity, because the maximum speed that was required was 600 megabits per second. So Cat5e and Cat6 with the 1000 base T supporting 1 Gbps were sufficient. For 802.11ac, the maximum speed is higher than 1 Gbps. For wave 1, it is 1.3, and for wave 2, it is 6.9. So we can no longer support this with Cat5e or Cat6 cabling. So we will need to use category 6A cable with the 10G base T that supports up to 10 Gbps. Now you can start to see the relationship between all these terms here. At the very top row is the IEEE specification. The second row, the megabits per second and gigabits per second designations, and basically the speed of your network. So how fast these devices are designed to support. The gigahertz is the frequency that these technologies run on, which is one of the most important factors determining the speed and coverage. And the cabling infrastructure is designated with category 5E, Cat6 or Cat6A. Now the base T is just an IEEE 802.3 physical layer specification for category 5E, 6 and 6A infrastructure. I know it gets a little bit confusing at first, but once you start seeing the relationship, it should be simple to understand. So let us get into the cabling structure. I will show a larger image of this diagram. But basically, the main difference between these two most commonly used designs are used for a cellular pattern versus a uniform cell design. So you can see the cellular patterns over here and the uniform design over there. Let us look at some older wireless cable structure. Again, this is just an example of many designs that are out there in the market, but this design closely resembles the design that were recommended by ISO, which is using the cellular pattern. So basically, the design is from ISO IEC TR 24704, which is the technical report for customer premises cabling for wireless access points. This standard recommends placing a wireless access point in an array of tight-fitting hexagonal cells with no more than 12 meters in radius, with the outlets close to the center of the cell. The outlet location is usually the location of the access points in this case. So let me show this in a very simplified lifestyle image, and you can see that there are 4 wireless access points placed in a hexagonal pattern, as you saw earlier. The one thing that you may notice here is the direction of the signal. So older devices like 802.11n and G have a signal that is omnidirectional, which means it splits the signal everywhere in a circular motion, hoping to hit one of the wireless devices that are out there. Remember, back in the days when we moved around with the wireless devices to find the best spot, this is the reason. Now, although this ISO recommendation is not specific to any Wi-Fi specification, the combination of this design with the signal direction of older devices makes this recommendation more suitable for older Wi-Fi networks such as IEEE 802.11n or lower. On the other hand, TIA recommends a very specific way to design for newer Wi-Fi networks. TIA TSP 162A, which is the telecommunication cabling guidelines for wireless access points, recommends using 18.3 meter uniform cell design as shown on the right of the screen. This design gets very specific in the cable type and length. Basically, what it is saying is once you divide the space into these uniform cells, pull two Cat6 cables in each cell, and the length between the patch panel and the equipment outlet should be no more than 80 meters. And that is your permanent length. Again, patch panel to the equipment outlet, here is the permanent length, and it cannot be more than 80 meters. Also, in the cell, the WAP cord should be no more than 13 meters, and the maximum length of your equipment cord in the telecommunications room is no more than 6 meters. So this entire length from the switch to your WAP is your channel, and this design will give you the highest chance to meet the theoretical speed that the specification is designed to support. Again, this is a simplified lifestyle image. You see that each cell gets two Cat6A cables, even if you are not using them all. So you can connect each cable to two different WAPs, or you can connect two cables to one WAP for a link aggregation to increase speed, or you can just use one cable and leave the other cable unused for future use. So this is basically a future-proof design. Now, one thing that you may notice on this image is the Wi-Fi signal is not circular like 802.11n. This is because 802.11ac uses a technology called beamforming, which sends a concentrated signal by communicating to the client. So instead of broadcasting the signal all different directions, it finds exactly where to send the signal. So going back to the design, this is a highly recommended design for 802.AC wireless performance. There is another TIA recommendation based on the number of people. TIA 4966 is the telecommunication infrastructure standard for education facilities, and it makes a recommendation based on occupancy size. So they are recommending putting one wireless access point per 25 people, or one access point for 230 square meters, or in very noisy environments with the high RF interference, concentrations like DOMS, place one access point per 150 square meters. And this is a great design guidelines for school and colleges and educational environments. Now, I think it's a right time for me to take a little pause over here, and we would like to open for a poll question for you. And the poll question for you actually to which type of wireless access points do you expect to install in next 2 years? And your options are 4 over here. You can choose any one. So if you can click on your choice and submit, we will have your answers. Okay, so you have option A, 802.11n, option B, 802.22 AC, wave 1, 802.22 AC, wave 2. Okay, so we have the answers over here. And I am really, really happy to see the result. 62 people, or 43% actually, I would say, you have gone with 802.AC wave 1 actually. This is slightly wrongly printed over here, but let me just correct it. The correct is 802.11 AC wave 1 or wave 2. So 43% have gone for wave 2. That's good. And 40% is for the next generation, have selected 802.11ax. So thank you so much for taking part in our poll question. Now, let us move on to the new standard. So far, we talked about what is currently out there in the market, and some of you, or most of you probably are familiar with a lot of them. This section focus on the new specification that was recently introduced. So first, let's stay with the IEEE 802.11 specification. There is a new standard in the works, which is called 802.11ax, or the sixth generation, or Wi-Fi 6, we can call it. This specification is expected to be released this year. I don't know when the correct time for release due to pandemic, but it's expected to release in this year. So we will not get into specific parameters until it is released. So what is the main driver for this continued development? We know that things are changing so fast, and we are seeing a huge increase in network requirements. Bring your own devices continues to grow. We are looking at a compound annual growth rate of 57% for mobile devices, and almost 50% for tablet adoption in enterprise space. The voice over IP, or voice over Wi-Fi, my apologies, voice over Wi-Fi is expected to grow 52.9% in this year. So it is very clear that wireless has transformed from a nice to have to a must have, and we rely so heavily on wireless, and we expect faster speed, improved reliability, and overall increased efficiency. So what is the sixth generation of Wi-Fi, or 802.11ax? Keep in mind that these specifications have not been released, so rather than getting specifics into the numbers, I will highlight the goals of this development and some major improvements from the previous generations. So there are three major goals for 802.11ax. The first one is supporting high density applications such as airports and stadiums. One of the challenges that we face with Wi-Fi networks today is supporting high density environments. So through improved multiplexing and signal modulation techniques, the goal of 802.11ax is to support ultra high density environments, and at the same time increase the average client throughput speed by 4 times. And very importantly, it will improve power efficiency, specifically for IoT applications. Unlike other wireless networks, IoT is connecting hundreds of devices, so it requires more intelligence in use of data and power. So there will be a new power saving mode technique called target wake time to negotiate the client to an access point. For wake time schedules to conserve power, which will result in significant power savings for power devices, specifically in the IoT applications. So again, the takeaway is 802.11ax allows Wi-Fi to service high density applications such as airports, stadiums and schools, and This will meet a growing need for IoT 4K, 8K video, augmented and virtual reality applications as well. Let us quickly compare the four elements that we discussed earlier today with 802.11ax in the mix. So the preliminary speed target for 802.11ax is around 10 Gbps, and we are looking at about 14 gig. So we are expecting a minimum of 10 Gbps. So using the example we saw earlier, now we are looking at around 3 seconds to transfer a 5 Gbps file. Again, huge improvement from the previous generation. Another thing that is going to change with 802.11ax is the frequency. Now they are going back to using both 2.4 and 5 gigahertz frequency to allow flexibility for low data rates. Also, the plan is to improve coverage through implementation of a different multiplexing technique. So even though it is still running on 5 gigahertz frequency, you will have the speed and coverage at the same time. So when it comes to cabling, it does not change much. Category 6A cabling is already supporting 10 Gbps, and with the link of your aggregation, you can double that speed. So supporting 10 Gbps with the category 6A should not be an issue. Therefore, it is very important to design your network with future expansion in mind. If you pull two Cat6a cable today, this will last for a long time, and you will have higher net prism value and can maximize your return on investment. So as far as the structure of cabling goes, now this is the recommendation that you saw earlier. So how does the new structure looks like with 802.11ax? Again, 802.11ax has not been released, so there is no formal recommendation specifically to 802.11ax. However, there have been preliminary studies that the current TIA TSB 162-A guidelines can be used for 802.11 Wi-Fi deployment with two Cat6a cables per WAP. So this tells you again how important it is to implement future-proof design, specifically the physical infrastructure where it is relatively difficult to upgrade. Again, this is just highlighting different speed comparisons for 802.11 specification. As you can see on the right hand side, the 10 Gbps is for the 802.11ax or Wi-Fi 6. Now let's move on to non Wi-Fi or non-802.11 specification that we discussed so far is IEEE 802.11 Wi-Fi specification, but 2.5 and 5G base T, as the name explains, it is a physical layer designation focusing on the infrastructure cabling. Now, when the name was first introduced, it got very confusing with 5G cellular. Remember, this is not a 5G cellular. It is specified to support up to 5 Gbps, but the clearer way to say is 5G base T, and this is about Wi-Fi, not cellular. Both IEEE and TIA released the specification to support 2.5 and 5G base T in 2016 and 2017, and you can see the whole chart which shows the timeline for different technologies which were released in the past. So let me briefly explain what this is. It would be easier to understand if you actually see the graphics. So I will use this diagram throughout this section. So this is the current cabling structure for a Wi-Fi network requiring up to 1 Gbps. You saw this diagram earlier today as well. Now, the increase in wireless demand has pushed the network capacity and the threshold beyond 1 Gbps that Cat5e or Cat6 can support. So the ideal solution to support more than 1 Gbps is to upgrade the infrastructure and the device to support more than 1 Gbps. So you are upgrading cabling and connectivity to category 6A, and you are also upgrading active gears to a 10G base T 802.11 AC wireless access points. So ideally, this is the design that we want to get for the wireless networks that need more than 1 Gbps. Now, this is another pausing time for me, and which is open for a poll question. Our second poll question, and the poll question is: what is your main concern upgrading wireless networks to 802.11 AC or higher? And your options are 4, which is cost of equipment, time required to upgrade, disruption to existing work environment, replacing cabling to a higher category. And while you vote, just to remind that you can submit your questions in the question answer for the question answer session, and we will try and deal with that. Okay, so we have the result here, and 62% of you are saying replacing cabling to higher category. And I do appreciate that, and I do agree that replacing the cabling to upgrade, basically it takes time, and whole infrastructure needs to be changed. And that is why our recommendation for any new installation is to actually avoid future upgrades and to go with the technologies which are available today, which are future proof basically. So thank you very much for your questions. Really appreciate it. Now, even if you don't follow technology all that closely, you have probably already heard about the term 5G and thought, what is that? During this section, we will review what it is and how it may impact your network in the future. So what it is? Well, it's big for cellular networks. You may even hear people say some of the following things, such as 5G is a general purpose technology. It will be used in all aspects of society, including manufacturing, transportation, agriculture, and residential applications. You also hear about it enormous impact it will have on the infrastructure development for data centers, cellular towers, and even at the city level for city planning. And one other item that you might hear people talk to it or refer to it as a fulcrum for the Industrial Revolution 4. And this last one I particularly like because it really gets to the point that the 5G is really a tool that we will use for the so-called Industrial Revolution 4. So some of the technologies that you will see included in the so-called fourth industrial revolution are things like robotics, artificial intelligence, quantum computing, the Internet of Things, the industrial Internet of Things, 3D printing, and fully autonomous vehicles. And of course, last but not the least is 5G, you see here on this list. And just to take a quick little sidebar here, I would like to talk about the internet itself for just a moment. And when you look on the right side of the screen there, you will see that the internet itself has had several different stages through its lifetime. In the first initial stage, the internet was really used for people that communicate with other people and to collaborate with each other across long distances. The second stage is really about people communicating with machines or servers, and that's where we are today. A good example of this would be streaming a movie over Netflix or something like that. It's one person or a couple people interacting with the server, getting the data that they need served to them. The third stage of the internet is really going to be machine to machine. And this is where we are going as a society. This stage will be characterized really by machine interacting with other machines using data from sensors and probes to make decisions about what to do and when to do it without any interaction with people at all. So now that we understand what the fourth industrial revolution is, or what we expect it to be, we can start to examine the characteristics of 5G that will make some of these things possible. And the first thing we want to consider is millimeter waves. So these are simply signals whose wavelengths are on the order of a millimeter in length. So if you look at the distance between the crest of a wave to the next crest of the wave, it's on the order of about a millimeter. And if you talk about this from the perspective of frequency, these are signals that are in a 30 to 300 gigahertz range. And the reason that this characteristic is included in 5G is simply that the faster and frequency is, or the higher the number is on the frequency, the more bandwidth you have in the same amount of time. The second characteristic is small cells. And if you think about most cell phones antennas today, you probably think about the large 300-foot towers that stick out from the landscape and are easily spotted. Even the ones that you see designed to look like trees as you drive down the roadway, you can still tell those are antennas or cell phones towers. But with 5G and small cells, these miniature base stations will be put just about anywhere that they are needed. So this will be things like on utility poles, on the tops of bridges, on the sides of buildings. Some people are even talking about built into the infrastructure for the city, such as street side trash cans on public streets. So the base stations will be ubiquitous and in high density numbers, and they will use a lower power than with the current antenna systems used today. The third characteristic is massive MIMO, and MIMO is simply multiple input, multiple output, and the base stations that will be deployed for 5G will potentially have hundreds of these antennas, which is a sharp increase over the existing antennas, and this will allow for more or many low power devices to be connected to the network in an efficient manner. The fourth part of the 5G that we will talk about is beamforming, which we talked about earlier. And this is simply an intelligent way of choosing the path that data will reach the end device. And this will include knowingly bouncing the signals of high buildings, of other natural geographic features. And what this accomplishes is that it uses the available spectrum in a more efficient manner. The fifth characteristics that we will talk about is full duplex, and this is simply the ability to send and receive data at the same time between a device and the antenna. And in the end, this just ends up doubling the capacity at the physical level. So there is quite a bit of benefit to this. So here on the screen, I won't go through all this, but this is a list of the cellular technologies that are found today. So you can see that today the data rate is approximately 150 Mbps. The frequency is below 3 gigahertz, and the latency, which is simply the amount of time it takes for a device to send the request and receive a response, is a little over 50 milliseconds. If you look forward into LTE technologies, which stands for long-term evolution, there is multiple versions of that. So if we look at version 10, 11, and 12 that we expect to be adopted widely in 2020, the data rate has increased to 1 Gbps frequency is less than 6 gigahertz. The latency has been cut down to 10 milliseconds, and the number of antennas that are supported are approximately 4 to 8. If we take one step further, we look at LTE 13 and 14, we see the data rate have risen to 3 Gbps. The frequency is still less than 5 gigahertz, and the MIMO antennas have gone up from 4 to 8 to 8 to 32. And the latency has dropped down to 2 milliseconds. So those are all very good advances in the technology. And by the time we hit 5G, the data rate now has jumped up to 10 Gbps. We are looking at frequency as well, about 22 gigahertz. The number of antennas that can be supported jumps all the way up to potentially to 56, and the latency has dropped well below 1 millisecond. And that's important for some of the applications that we are going to talk about here in the next couple of slides. So we take all the applications that we run over 5G and put them into a triangle. We can start to sort them along these three different axes, and each one of these axes will require a different network topology in order to support it. At the top of the triangle, we have an enhanced mobile broadcast, and it's characterized mainly by just the raw amount of data that you can send to a device. So the network that will be used to support those kind of applications are going to be the high density deployments of the smaller base stations. It's going to use the high frequency signals so that you have the larger bandwidth. When we move down to the bottom right of the triangle, these are applications that are looking for low latency, but also ultra high reliability. And one of the good examples for this type of application is the self-driving car. You don't want to be in a self-driving car and have the network being dropped in and out, and you definitely don't want a lot of latency because you don't want the car behind you to end up rear-ending you. If we move to the bottom left side of the triangle, this is where we have the massive Internet of Things, or IoT, and this network will be characterized by low frequency, low bandwidth connections, but the ability to support many devices at a single time. So these real world applications that we will see, the first one that you are going to see is fixed internet. And we will talk a little bit more in the next slide. But the idea here is that you will be able to use 5G to either compete with or replace things like cable internet service providers or other wireless internet service providers. The second one is entertainment. And this is talking about things like 4K and augmented reality, where the raw data rate that you need to support these things can be quite high at times. The third is automotive, which includes vehicle to vehicle communications as well as vehicle to device inside the automobile. IoT is a large set of different sensors and other items that can be connected to the network, but don't really use up a whole lot of bandwidth on the network. And the last is wearable technology. Most people are already familiar with the smartwatches as well as Fitbits. Excuse me, and other devices like that. But really one other application that we could see here for wearable technology is in the healthcare space. So if you think about all the applications in the hospital, for instance, where you want to monitor the patient's heart rate or blood pressure, or whether they have moved around the room or not, there is a great opportunity here for the technology to really improve the way that we do healthcare currently. So the first application of 5G that most people will see is this idea of using 5G as fixed internet, and this will mostly impact fiber to the home deployments because 5G will be more cost effective to deploy. As far as the enterprise goes, it's unlikely to replace enterprise Wi-Fi in the next 10 years or so. So some final thoughts on 5G here. 5G will drive global cellular infrastructure improvements for the next 10 to 15 years. It will offer better service for mobile users and mobile applications, and it will bring more competition for fixed home internet for underserved locations. 5G will not displace Wi-Fi in the enterprise, most likely due to cost. So in next few slides, we will discuss our final thoughts to wrap up our webinar, but don't go away by saying we need to choose wisely. So do not go away in next few slides. Today, we covered most of the current enterprise wireless options we have today, and emerging options we know that are coming in the next few years. And this table summarizes these options. We talked about data, we briefly touched on cost, and we reviewed cabling structure and design. And based on a summary put together, it is evident that considering this data reliability of the network and the cost of implementation and use, Wi-Fi 802.11ac or higher combined with category 6A offers the best solution for enterprise applications seeking system longevity, faster data rate, and support for high bandwidth wireless networks. And remember, it is not just about wireless access points and switches. The design of your network and products that you choose will determine the overall performance of your wireless network. And when making the product choices, we need to carefully evaluate product features and value. Can the product support PoE, which is very important? Are they Planum rated for Planum based installations? Are they third party tested, or do they meet all the standards? So make sure that we are not just choosing products that are available at lower cost. We need to choose good and reliable products. Remember, there is no network that is only wireless. Good wireless networks always require a good wired backbone. Although you have variety of cost-effective solutions available to choose from, and category 6 is very much there at least choice. However, please revisit your decision in favor of category 6A based on our discussions around 10G requirement. Over and above, Wi-Fi is expected to use high power PoE. So consider that 100-watt PoE to be delivered on cabling infrastructure. Shielded cabling system will be the best choice to deal with PoE, heat dissipation, EMI, and alien crosstalk for 10 Gbps. Consider connectors which can handle the high power PoE, avoiding time damage while in use. Wireless access points are installed above the false ceiling. In most cases, many people struggle to decide on the outlet types. As standard wall plates or outlet we call it, or faceplate we call it, are not preferred choice, as some avoid it due to the security reasons, and some do not find space to install it, and that leads them to allow field terminated RJ45 plug, which may go terribly wrong if not selected wisely. This has now been addressed in the new standards, cabling standards I'm talking about, with a terminology called MPTL, or Modular Plug Terminated Link. To get the desired performance, MPTL needs to be tool free and must be field tested with patch cord adapter on the tester side. Another choice is to use surface mount box, which is easy to install, and we have seen so many years ago actually this surface mount boxes. You can install these above the false ceiling, or you have a choice of in ceiling bracket which holds the RJ45 jacks in place. So I'm done from my side in terms of talking. Open for question, and over to you, Devalt. Devalt, can you hear me?
Can you hear me?
Yes, I can.
Okay, thank you very much, Babu. Yeah, we have quite a few questions here, and please, people, if you want to, you could still submit some new questions. Babu, the first one up, I think you've answered, says, will Wi-Fi ever be replaced by cellular?
Well, as we see that in in FTTH, as I said, is a possibility, and we expect that to happen. But in the enterprise segment, we don't see that to happen. And one of the reasons which I talked about is the cost. And the other one is maybe I'm just speculating this as a security reasons for enterprises. So in the enterprise, we don't see that to happen for now, at least for so many years.
Okay. Another interesting one, why would only 80 meters of cable length be suggested based on TI TSB 162 instead of 90 as in the permanent link?
Okay, so this is very much practical enough, actually. Uh, if you recall that I said you choose 18.3 meter of square so that you install cables into it or with the outlet for Wi-Fi access points, and we recommended, or the standard recommends, 2 outlets per that 18.3 square area. Basically, your access points can move from here and there. It may not be at the center of this location. So basically, when you have 80 meter, a permanent link, that will allow enough space or enough length, which recommendation is not more than 30 meter of patch cord from outlet to the Wi-Fi access point. And this is basically to allow that 13-meter length to be accommodated. I hope that answers the question.
Okay, I understand that. And then I have a double-headed one here. Can we still use unshielded cabling instead of shielded as you recommended? And then the next question, part of that is for PoE, would it be better to use shielded or unshielded?
Okay, this is a very good question, close to my heart. The answer is yes, you definitely can use unshielded solution. I don't see any issue other than if you can mitigate the issues of EMI, Allen crosstalk, and PoE, perfectly fine to use unshielded solution. My recommendation for shielded solution is because shielded is, we can say, nice to have. It's not must to have, but I would say nice to have instead of unshielded. So my vote actually goes for shielded cabling solution because we are dealing with higher frequencies, more electromagnetic interferences. There are a lot of wireless devices around us. So my vote goes for shielded, but yes, definitely you can use unshielded solution. In terms of the PoE, it's your actually task to check the selection of cabling which you are doing, whether they comply with PoE. Now, PoE is a different subject altogether because it takes a lot of time to discuss. I have touched base on 100 watt of PoE, which is the need of today. And you need to make sure the cabling system you are choosing, not just the cable, but including your connectors, patch cord, everything must comply to PoE 100 watt, which will actually leave the space for you to deal with any PoE, whichever is 100 watt or lower. I
Okay,
hope that answers the question.
Yeah, you know what, we've actually got quite a few. I'm going to ask you one more because I think we are running out of time, but I think this is quite interesting. The person asked, if we are upgrading Wi-Fi AC to AX, will a fiber backbone OM3 be sufficient?
Yes, OM3 will be sufficient if it is an enterprise segment. Basically, we are talking about backbone from what we call, either you can call it building distributor or main distribution to the flow distributor. And that does not basically exceed hopefully 300 meter, which is good enough to run 10 Gbps of application up to that distance. So I don't see any need of changing fiber backbone while upgrading your cabling infrastructure.
Okay.
I hope that answers the question.
Again, I think it does. Yes, thank you very much, Babu. I hope you've all enjoyed Babu's presentation and that it's expanded your knowledge on wireless, enterprise wireless in particular. As I've mentioned before, please don't miss out on Bixie's promotions. Use that code EMEA WEB03 on the slide. You can see it on the slide there if you want to unlock that 10% discount on the manuals and the standards, but it has to be within 30 days. So you've got 1 month from now to do that. Should you be considering becoming a Bixie member, now is the time. Remember that joining fee will be waived for 30 days after this webinar. The courses I've mentioned, especially for the RCDDs, some good CECs there that you can get. A lot of them are free. There should be a box that is popped up on your screen where you can please answer 4 questions for feedback. And while you're filling in your answer, please, just another reminder that this webinar provides 1 CEC. The CEC will be awarded to your credentials and reflect online within 30 days automatically. You don't need to do anything from your side. And then also remember the 2020 Bixie EMEA conference in Dubai. Registration is open already. It'll be from the 6th to the 8th. We'll be offering high quality international agenda and many exhibits which are showcasing the latest products, solutions, and projects. Please take a look at the event website. And if you or your company would like to participate, please contact us. The email address is on there, bixie.org, EMEA 2020. It's always been worthwhile. I must say that it is very high class, and I've seen some world-class presentations, and it is also an ideal place for people to launch their new products. So it's certainly worth your while. Again, thank you to Leviton for bringing this webinar to us, and Babu, it was a great presentation. Thank you very much. Any other questions on the presentation, please contact Babu. We've supplied his email address. If any other questions are for Bixie, please use the same EMEA address. And then depending on where you are, have a great morning, afternoon, or evening. Bye-bye.
Thank you. Bye-bye.